So here in this problem, we are given with the value of sine A, so that's 3 over 5. Cosine of B is negative 12 over 13. With a condition that angle A and angle B lies between pi over 2 radians and pi radians. So using this information, we need to obtain the value of these three trigonometric ratio. So let us begin. Now, let's first state the formula for each of the three trigonometric ratios. So we have sine A plus B. Now sine A plus B, that can be expanded as sine of A times cosine of B plus cosine of A multiplied to sine of B. Then we can also define cosine of A plus B. So cosine of A plus B will be equals to cosine of A times cosine of B minus sine of A multiplied to sine of B. Now to find out the value of tangent of A plus B, what we'll do after we obtain the value of sine A plus B and cosine of A plus B, we'll take the ratio to find tangent of A plus B. Now let's begin with sine of A plus B. So here we are already been provided with the value of sine A as well as cosine B. That means we will now have to find out the value of cosine A and sine B. This is similarly true for cosine of A plus B. So let's begin by finding out the value of cosine A and sine B. So let's begin. So here we are given the value of sine of angle A. So that's equals to 3 over 5. Then how do we find out the value of cosine of A using sine of A? Because we know that sine squared theta, that's a very standard identity. When added to cosine squared theta, this gives us the value equals to 1. Meaning, if we want to find out the value of cosine theta, we can rewrite this equation as plus or minus square root of 1 minus sine squared theta. Similarly, if we want to find out the value of sine theta, we can rewrite the original equation as plus or minus square root of 1 minus cosine squared theta. So in the case, we have to find out the value of cosine of A. So we can use the formula plus or minus square root of 1 minus sine squared A. What we're doing, we're replacing the value of theta with the angle A. So let's plug in the value of sine A with 3 over 5. So we have 1 minus 3 over 5 whole square. So that's 9 over 25. And when we solve this, we're going to get the value plus or minus 4 over 5. So here we are getting two values. One is a positive 4 over 5 and the other is negative 4 over 5. But it's already given here in the problem that angle A lies between pi over 2 and pi. What does it even mean? Well, let's try to understand using our Cartesian coordinate plane. So here we have the first quadrant where the angle lies between 0 and pi over 2. In the second quadrant, we have the angle lying between pi over 2 and pi radian. In the third quadrant, we have angle lying between pi and 3 pi over 2 radians. And we have a fourth quadrant where the angle value will be between 3 pi over 2 and 2 pi radians. Since it's given here that both angle A and angle B lies between pi over 2 and pi radian, meaning our angle A as well as angle B is lying on the second quadrant. Now in the second quadrant, which trigonometric function is positive? For that, we'll have to remember the mnemonic A, S, T, C. This is measured in the anti-clockwise fashion. Here S stands for sine, meaning in the second quadrant, the trigonometric ratio of sine and cosecant, these two functions are going to be positive. Everything else is going to be negative. Now since we are dealing with cosine of A, that means cosine of A must be equals to negative 4 over 5. So we'll have to use this particular value. Now we'll go to the next one. We are also given here the value of cosine B. So that is negative 12 over 13. So here is we have a negative value. So let's let's verify that why it is negative. Since it is mentioned that B lies in the second quadrant, and in the second quadrant only sine function is positive. So that's why cosine function, cosine of B is a negative value. Now that we have cosine of B, we can immediately find out the value of sine of angle B. So sine of angle B, that will be equals to plus or minus square root of 1 minus cosine squared B. We have replaced the value of theta with B by using this particular formula. So let's replace the value of cosine B with negative 12 over 13. So we have 1 minus. So negative 12 over 13 whole squared will be 144 over 169. So that will be equals to plus or minus 5 over 13. Fine. So this is the value of sine of angle B. And since we are in the second quadrant, sine function is positive. So our final value for sine B, that is going to be equals to positive 5 over 13. So we have the value of sine of angle A we have the value of sine of angle B. We have found out this has already been provided to us, the value of cosine of B, and we have obtained the value of cosine of A. So let's use these four angles to find out the value of sine A plus B as well as cosine of A plus B. Let's begin with sine A plus B. So number one, sine A plus B, so that will be equals to, we have sine of A, so that's 3/5, multiplied to cosine of B, so that's negative 12 over 13, plus cosine of A, so cosine of A is negative 4 over 5, multiplied to sine B, so that's 5 over 13. So this is going to give us a value, negative 56 over 65. Then we will move on to the next one, which is cosine of A plus B. So we need cosine A times cosine B, that was going to be our first term. So cosine of A, negative 4 over 5, multiplied to cosine B, so that's negative 12 over 13, minus sine A times sine B, which is the second term. So sine A, that's 3/5, multiplied to sine B, so that's 5/13. Solving this, we get 33 over 65. Now we can finally find out the value of tangent of A plus B. So tangent of A plus B, that's equals to the ratio of the sine function, which is sine of A plus B, to that of the cosine function, meaning cosine of A plus B. So sine of A plus B, 56 over 65, divided by cosine of A plus B, so that's 33 over 65. So we get negative 56 over 33. So hence we have successfully obtained the value of sine A plus B, so that came out to be negative 56 over 65. Cosine of A plus B comes out as 33 over 65, and tangent of A plus B, that comes out as negative 56 over 33.